example 6 will come up later again, but just out of interest, if I have cosine y is equal to x, it's asking you to find the derivative implicitly and then find the largest interval closest to the origin for which y is differentiable. Okay, so we're going to take the derivative with respect to x on both sides. That gives me on the left-hand side negative sine of y times, using the chain rule, dy dx, and then is equal to 1. So dy dx is equal to 1 over negative sine of y. I could also move the negative up if I wanted to. But just an interesting insight here. You know, sine, our function looks like this. Same on this side, negative pi. So for it to be differentiable at a value, you can't have something that's undefined. So you got to look at where sine of y would be equal to 0. Well, that would be happening at 0 and at pi and at negative pi. So if I'm finding intervals closest to the origin, I could either, so the intervals I could use is either from 0 to pi, because at 0 and at pi, it would be 0. So that's an interval closest to the origin. Or it could also negative pi to 0 would work for that. Otherwise, we would end up having parts of the interval be undefined. An interesting side note on this one, by the way, is that I know that sine squared y plus cosine squared y is equal to 1. That's a Pythagorean identity. So that means sine squared y is equal to 1 minus cosine squared y. And sine of y would then be equal to the square root of 1 minus cosine squared y. Okay, that's cool. So we get, I could rewrite this as dy dx is equal to negative 1 over the square root of 1 minus cosine squared y. You might ask me, oh, Mrs. Pointer, that seems more complex than we had. But what's interesting here is that, look, up here, cosine of y is given as x. So that means I can rewrite this as dy dx is equal to negative 1 over the square root of 1 minus x squared. So in that case, if I know what x is, I can then find dy dx. Another interesting fact is, look, if I had the function and I wanted to solve this for y here, this would mean I would have to take the arc cosine of both sides. So I would say, okay, well, that would be equivalent of saying arc cosine of x. So in other words, the derivative of arc cosine is actually negative 1 over the square root of 1 minus x squared. Example 7. Now we really have to pay attention. It's asking for the second derivative. Now, if you have an old version of my notes, the b, I decided to change b. So if you could go and fix that, I'm sorry. I realized once I did it myself that the problem I'd given was really complicated, and I didn't mean to make it that complicated. So if you could change it, or else you might have my newer notes, don't worry about it. If I'm finding the second derivative, my first job is to find the first derivative. Take the derivative with respect to x on both sides. We get 2x plus 2y dy dx is equal to a constant. So first job, find dy dx. dy dx in this case ends up being negative x over y. So now to find the second derivative, you just take the derivative of the first derivative. So with respect to x, I'm going to differentiate both sides right now. So in our case on the left, we get the second derivative, which is what we wanted. It's equal to, and there's a couple ways you could do this. Because there's two variables, maybe using the quotient rule might not be too bad. So then we do ho times the derivative, so d high is negative 1, minus high d ho, but be careful because you're taking the derivative of y, it's going to be dy dx. We're taking it with respect to x. Draw the line and square below. So let's polish this off a little bit. That's going to give me negative y plus x times dy dx, okay, over y squared. But I know what dy dx is. I figured that out up here. Up here is dy dx. I can replace the dy dx by that. So let's polish it off a little bit. So the second derivative will now look like negative y plus x times negative x over y squared. And then I'm going to do a little bit of algebra. First of all, we're not going to have a fraction within a fraction, so I'm going to multiply the numerator and the denominator by y over y. So that's going to give me negative y squared minus x squared over y cubed. You could factor out the negative if you wanted to, but you don't have to. And that's the second derivative for x squared plus y squared is equal to 4. Now pause it and try part B, but try the newer version of it. This one is a little more complex than what we did, but if you can do part B, you can do them all. All right. On your TI-80 9s, you can actually use implicit differentiation. Some newer if you have an older one, you may not have it on there, but you can always ask to download it through TI Connect. It should be in the F3 menu on the home screen, and then if you use the arrow down key, there is an IMPDIF. It might be double F, I forget. And then right in the equation, you want to take the derivative with respect to x of y, and then hit enter, and hopefully it'll give you, it might have factored out a negative. Sometimes it reorders the terms slightly different, but this is how to use your calculator for it, to at least check your answer.